Welcome to Securing GraphQL from design to production. It's a real pleasure for me. I've been able to come to BSides here in the last couple of years, and so it's really nice to get the opportunity to present here for all of you. So at the end of this talk, I'm hoping you will understand how these small little requests that we got once every 5 minutes coming into our work environment caused a denial of service attack for our back-end systems. Hopefully for those of you that are pen testers and coming across GraphQL, have a few more ideas of things to try and do for testing. And for those of us helping to build secure applications with GraphQL, some more things to kind of keep in mind at the development stages. So quick little bit about me. This is how my 3-year-old thinks daddy works, which is not completely wrong, but I do have slightly better typing skills. So for this particular talk, I was a former director of product security at one of those tech unicorn companies that made a lot of use of GraphQL. So the stories that I have here for you today is from my experience with them. I've recreated a lot of the sort of services, the requests, and the responses. So these aren't the actual services anymore, but it captures the idea of things that we actually had reported to us through our bug bounty programs, through our pen tests, and our other reviews. I'm going to assume you're all a little bit familiar with REST APIs, and if you got to Corey Ball's talk earlier in track 2, that was a great sort of fundamental sort of foundation for what me and the team understood about sort of security for REST APIs and endpoints. But as I started with this company in 2019, they are already starting to use GraphQL, and my whole security team, we kind of had to come up to speed and realize those differences between securing REST endpoints versus GraphQL. And over my time there was about a dozen or so different GraphQL services that they had in place, but they pretty much lumped into these 3 different categories. We had internal services, GraphQL gateways. We ended up developing a GraphQL gateway for all of our mobile apps to use. And then finally, at the end of my time there was a partner API that we developed to help our external partners integrate with our systems. And it was really our development team that was driving this adoption for GraphQL. It really created a useful abstraction for them with their microservices, being able to kind of continue to develop and change things and not break things for the clients that were reliant on them. So they're really kind of the ones that helped drive the adoption of GraphQL. We weren't using MCP at the time or any LLMs, so we didn't really have GraphQL integrated with that, but it's kind of the new chocolate and peanut butter works really well together technology. So if you haven't hit GraphQL yet, I got a feeling you might be experiencing it more and more here with the current hotnesses. And if you know anything or have heard anything about GraphQL versus REST API security, you've probably heard about introspection. So introspection is special queries that can be sent to your GraphQL server and returns information in the response about the whole schema for the GraphQL service. So any queries and mutations it supports, any of the objects, any of the field names, all contained within that schema. So anything your developer needs to know to understand how to make a request to that service and get the data back that they want. Obviously, as an attacker, that's great information to have as well. It's like somebody publishing their API documents out there online for you. And so if you've ever come across this sort of interface, this UI before, this is GraphQL Playground. It's really popular. And off to the side was usually the schema and data section that you can expand and start poking around and seeing that information. And all that's coming from parsing the response from one of those introspection queries. Now, if you ever get your GraphQL service pen tested, you have introspection enabled, expect you're going to get that as a finding. So we disabled introspection in production, but as we were doing our own internal reviews, we'd either test against a staging system with it enabled or get the schema from our development team and use that as part of our security reviews. And what we ended up finding out after a little while, a really helpful way for us to understand that schema a bit more was to actually visualize it. So this is GraphQL Voyager. It's not meant to be a security tool necessarily, but our team found it extremely helpful for helping us understand the relationships within the graph and kind of visually quickly understand and see things. Similar to GraphQL Playground, it's getting all this data from sending an introspection query and parsing that response. But in this case, it's parsing that response into this interactive web page that you can use to drill down on the different objects and relationships within your graph. If you're using Burp Suite as your sort of testing tool, there's the InQL plugin. Thank you for Xavier for pointing that out to me. It's been a great tool and resource to use. It makes it really handy if you're actually testing a GraphQL interface and formulating your queries, but also it now has GraphQL Voyager built right in. So if you want a real simple way to just kind of pop that open and take a look visually, that's a really handy tool. Like most things in Burp, if it's a really large schema that's taking up a lot of memory, you might have to walk away for a little while, let it load, and come back after a day, but it's still really handy. So let me show you how these relationships ended up impacting us at the place that I previously worked at. So I realize this might be a little hard to see, so I'll kind of talk a little bit about it here. On the left-hand side, we have the GraphQL query that our mobile app was sending to the service. And over on the right-hand side, this is the response data that was coming back. I apologize, a lot more of these down the line are hopefully going to be clearer to read in the back. But basically, our mobile application was searching our locations over a certain time period and asking for any bookings that were already being taken place at that location. And so that was the data you're getting back on the right-hand side. So UUIDs, timestamps, publicly available information. Our security team was perfectly fine with this information being returned to the clients. But if we took our graph and we actually visualized a simplified version of that schema around how we were handling those bookings, this is what that graph would have looked like. So we do have our booking object there in the middle. We got our booking UUID, our start dates, a relationship over to the location object that had all that building location information. But probably jumping out at you already is that there's a relationship to a user object as well, which made logical sense. It was our users of the system that were making these bookings. They'd have to own these bookings in some sense. But our client side wasn't requesting this. But since we do see that it's here in the graph, it is something that we could form a valid GraphQL syntax for and see if we can return that data along with it. And GraphQL makes that really easy to do. You just say, hey, can I have that user object? I think I saw that there was some PII around there, first name, last name, email address. Great, return that to me. And oh, also, wasn't there a payment object related to this? There was, and all that data did come back. So this was something that kind of was an eye-opener to us and understanding these graph relationships. Well, I talked about this in context to introspection and having that schema and being able to visualize it and see those relationships on how to ask for the data in GraphQL. Really, the issue here is that we didn't have the proper auth checks around when we were allowed to have access to that user object. So that was what our fix was to basically build into here. And in fact, we had introspection disabled on this service. I mentioned it came from our mobile app. So the person who reported this to our bug bounty actually did it through decompiling our mobile app, looking at all the different GraphQL requests that we were sending, and kind of building their own schema and understanding that this relationship existed. So this was sort of a wake-up event to us on the security team of using Voyager more and understanding those relationships in the graph and start looking for them. And in fact, this almost happened to us again when we developed our partner API service. So our partner graph was quickly becoming this everything GraphQL API. So it have low-risk operations like what time a building was open and hours and stuff like that, but also these really high-risk queries and mutations like getting invoices and doing billing and payments. And so this really caused a lot of those relationships to be there between high-risk and low-risk sort of objects. To some degrees, we try to separate that out. I think at one point we worked with having maybe a public user object and then a my user object for more of those internal things that somebody would set for their account. Ended up causing a lot of confusion and being a lot more complexity than what our developers wanted. Like I was saying, this partner API was turned into this everything app. And just because you can add everything together into a single graph, it's not always the best idea. We definitely experienced our graphs growing larger and larger and larger. But we did look to Shopify as a good example of one resource where they split out their admin GraphQL API from their user API, their storefront API as they call it. So this was something we referred back to again and again as we were figuring out how we were going to separate these services and not lump everything into one single graph. One last introspection related item that I want to talk about. So, as I mentioned, we would disable introspection from our graphs, but we had a number of times where the graph was still trying to be a lot more helpful when it came to any errors or typos. So if you didn't know for it, like in this example, that it was a user object and you just guess like, maybe it's called username. Do you have one of those? The error message over here was trying to be helpful. And it's like, oh, I don't have username, but we do have user. Disabling introspection and disabling either these hints or suggestions is often two separate flags in most GraphQL implementations. So you'll want to check for that. Now, if you're like me and you're coming from using a lot of your web server request logs as sort of understanding how your users were interacting with your different REST API endpoints, those logs are going to be probably a lot less useful for you when you come into GraphQL. And a big reason for this is that all your GraphQL requests, introspections, queries, mutations, they're all post requests to the same endpoint. So if you want to understand what your users are actually asking for and doing with your graph, you're going to need a lot more logging in your application side to get that data. And if you're starting to do that, one of the things that we learned is that the operation names are optional, and users can kind of alter those and choose whatever they like in most cases. So if you are going to try to tag those or log those operation names, make sure you do that with something you have tagged on your server side. Also, we had instrumented our logging system to do alerts based on a lot of 500 error messages. But in a lot of cases for GraphQL, if there's errors, it's actually going to log a 200 OK message and package those errors in its response to the client. So I'll show an example how this kind of got us a little bit later down the line. But that's something to be aware of as well, is that you'll probably see a lot less of those 500 errors in your logs once you move to GraphQL. And the other logging feature that we found we needed to implement more was having a consistent request ID associated with each of our requests that came out of our GraphQL service. Typically, we'd have one query that would come in to our GraphQL, and then that would spawn maybe a dozen or so different requests to our backend services. Having a request ID that would tie all those different backend requests with the same client-side request that we got was something we found we actually had to build into our GraphQL system for us. So with those error messages, I sort of mentioned that it's always going to typically log a 200 OK message for those, and then package the errors in the JSON response, as long as you have valid GraphQL syntax. Originally, our GraphQL developers really liked this approach because their team was responsible for the graph and not most of the backend services. So graph was running fine. You know, here's the error message from the backend service. Go and talk to this other team. That's where your issue lies. And on the security side, you know, we got our GraphQL system pen tested. We were looking for verbose error messages. We checked the configuration for that. It wasn't enabled. But there was more and more backend services being connected to the graph. Most of those had verbose error messages disabled, but one of the days something changed. One of those connections changed. And it was a pretty subtle error message. You know, we don't get a full stack trace here. It was just kind of a URL that was part of that response. And tacked on to that URL was also the API key that we're using to communicate to that third-party service. So basically, anybody who saw that error in detail, what it was, they completely bypassed going through our front end, didn't go through our WAF or any of our other sort of security controls, just directly connect to that third-party service. So obviously, we had issues around how we were authenticating with that service that we could improve. But this event was sort of our wake-up call that we wanted a better way of handling error messages with GraphQL. And fortunately, most GraphQL implementations actually do offer a very simple sort of catch and formatting for error messages. This was a great way that we could say, hey, we know these error messages are helpful to our clients. They're coming from systems that we've worked with before. We have good validation around that. But we're going to have a default generic error message that's returned in all other cases. And so that was something that ended up being really useful and helpful for us, but it was also something we needed to help our developers understand to build in early on to sort of the GraphQL development process and not have it be a last-minute thing that came back to them from the pen test. One last big topic I wanted to touch on was rate limiting for GraphQL. As you can already imagine with what we just talked about from the differences from GraphQL to your REST endpoints, if you have rate limiting rules set up in your WAF or gateway firewall around sort of REST request, those aren't really going to translate as well to helping protect you from different GraphQL attacks. In fact, it's normally a feature of GraphQL to take what used to be multiple REST requests, package them into one GraphQL request, so your client's actually interacting with you less. But this can lead to two types of attacks that we frequently see with GraphQL. They're kind of query stuffing attacks. There's sort of this idea of a depth attack and a breadth attack. Creating this depth attack is sort of this recursive GraphQL query that's really compact and usually simple for clients to figure out and send to your service, but it can cost a lot of resources and time for your server to actually process and handle. This very simple generic example here is you can imagine you have a store web front that has products in it. Those products belong to a store that has products in it that belong to a store that has products in it, so on and so forth. And this is all very valid GraphQL that you could ask for. Most GraphQL implementations do have a simple configuration setting to say this is the maximum level of depth that I want. It may take you a little bit of trial and error to figure out what's the right setting for your environment, but that's usually a pretty easy problem to solve. Where it gets more complex is this idea of breadth, where somebody can just ask for this very large query with lots of different objects, and some of those may be very simple for your system to return and gather, and other ones might require a lot of resources in your back end to piece that data together. And that's basically what led to this issue with our services here. Here's these Splunk logs again. This is a single request. It was spaced out every 5 minutes, and when this hit in the evening time, our internal service would be DOSed for 15, 20 minutes or so trying to handle these. And at first, we didn't even think what was causing the problem was happening through our graph service. There wasn't a whole lot going on in these logs. There wasn't a whole lot of traffic or other activity. We had some of those logging issues like I mentioned earlier. But then when we dug into here, we realized that some of these request response sizes were really huge. And that was sort of our tip-off that, okay, something weird is happening with these queries and the service. So as we started digging more into it, we realized that this was actually one of our partner teams externally sending a request that was basically scraping our locations for all those booking informations like we showed earlier. They actually thought they were being very efficient with how they were formatting their query, which is true to a certain degree, they were, but they had no visibility into what that was causing to our back-end systems. So in our case, it was, the DOS was coming from inside the house. We could just reach out to that team and say, hey, we got to restructure this query and how you're accessing the data. We added some more data loading to make these systems more performant. We also changed the size of our overall post-request buffer that we were allowing in, because it didn't need to be as large as what they were doing. So we had some pretty quick fixes for our issue, but really it started us down a path for a long-term fix, which is needing to be able to calculate the cost of these GraphQL queries and requests coming into our system. And so basically you needed to do the cost at 2 different points. One, how much does this query or mutation actually cost you and our systems? But then also a way to look at a GraphQL statement before we actually run it and figure out how much this is going to cost our system and what's a reasonable limit to expect. Like with most rate limiting tools, a generic one-size-fits-all out-of-the-box solution is probably not going to give you the security you need for your systems. And so there's a few tools that let you get as deep with this as you want. And typically it means adding annotations to your schema and saying how much each of these operations is going to cost you. But you'll need a way to sort of figure that out and decide what makes sense. We really look to GitHub and Shopify again. They have some great blog posts about how they've set up their rate limiting rules. And if you're using Apollo, which is really popular, they actually point to an IBM study about how they went through GraphQL and started figuring out what costs should be in most environments. I did want to talk a little bit about what we learned from doing pen test against all these GraphQL services, what worked well for us and what didn't. What didn't work well was just saying, here's the website, introspection's enabled, go for it. We definitely found to be better with our pen test, we would try to include as much documentation for our pen testers as possible. While we couldn't share the actual code for our projects, we would have them test in a staging environment with introspection enabled. We'd also share with them any of the saved queries and mutations we're using in our CI/CD pipeline for developers to test things, as well as any queries that we would save on the security team. And a lot of times we sort of had a postman package that we would allow the pen testers to use. And seeing what some of that default data looked like and what a valid response should be was a huge time saver and really made the pen test a lot more efficient. Also during the kickoff calls, we would demo GraphQL Playground and Voyager for them. We would talk about what queries and mutations were more high risk for us and costly. And if we did have any rate limits in place, explain to them what those rate limits were and if they could bypass them. I know I couldn't cover everything, all the security features of GraphQL. Obviously, you want to keep the whole OWASP top 10 in mind. There's a great OWASP cheat sheet specifically for GraphQL nowadays. So that's really handy. And so with that, thank you all for coming. I'm local from around here. I'll be in the hallways. I'd love to chat with you about this or anything else afterwards. Thanks very much. The website has the slides on it. And also, if you're in the CTFs, there might be a little something extra on there for you, as long as it stays online. Thanks.
All right, so the question is, again, I understand this is likely a business decision, so very case specific, but from somebody who doesn't do a lot with GraphQL, where do you draw the line between implementing controls at the GraphQL endpoint for like rate limiting and cost versus like data structure design and SQL queries and like whatever's doing the stuff on the back end? Because it seems like they're kind of at contention, right? Like you always want to be more efficient than your GraphQL endpoint can do more, but where, like, how did you draw that line in the sand?
Yeah, no, and definitely that was difficult, and I think something like our development teams kind of went back and forth with. In some cases, it was easy when we were designing sort of like the mobile client that was talking to the GraphQL gateway, but in other ones that were supposed to be publicly accessible and we didn't really have a good sense of what queries might be coming to our system, it was really sort of a back and forth. And typically with most security sides, you know, we're fighting for sort of a tighter control around the rate limits and the cost, and our developers would kind of want it more towards the looser end. So in a lot of cases, that was really where sort of tracking like performance metrics with the GraphQL service and the backends was something that we needed to look into. To an honest degree, like only some of that decision was part of the security team. A lot more of that had to be done by the engineering team.
Fair, okay. So like you use OTel data or something to tell you about what's happening on the back end for all that? I suppose money talks, right? Whatever's cheaper to implement.
Whatever's cheap to implement. I mean, you know, we did pay more to have Splunk at certain points and stuff like that, and that's what we're using for a lot of our metrics before we moved to APM. Yeah, there's not kind of I wouldn't say that you could have all your controls just in the front end. There was definitely like a lot of times where it's like we need to rely on the back end API to have like the proper rate limit controls around how many requests or how much time we'd allow this to take.
Okay, fair enough. Thank you.
Yeah.
Hi, thanks for the talk. I missed the first part of your talk. So you're on a security team at a business, or?
I was the director of product security at a company using GraphQL.
Have you had much success or any effort in controlling like developer API allow list like endpoints, or it sounded like sort of the rate limiting was kind of along the same lines, because we've looked at it with like Swagger docs through the WAF, like this isn't in the Swagger docs, so the request isn't going to work. But then kind of we always backed off on it because it seemed really sticky. So I was wondering if you had any experience with that.
Sorry, what part exactly with?
With API endpoint, like allow listing, or if the rate API GraphQL rate limiting with kind of passing that down to the dev teams, if you've had any experience or success with that, and if it's as sticky as it sounds, or if there's something that you...
Yeah, I guess to a certain degree with, like I was kind of mentioning with the rate limiting, it's going to work differently with GraphQL, how you really are going to have to need to kind of calculate these costs to go along with it, besides just setting like I'm allowing these number of requests to come into my service, or this amount of requests coming from our GraphQL gateway to the endpoints. You know, we basically had to make an allow list for the GraphQL service to bypass any of the regular REST API rate limits we had in place, because it was our gateway and funneling traffic from multiple users in a lot of cases. So we did that, and then you were kind of asking a little bit about an allow list, and it was really part of our GraphQL implementation itself that would determine which API endpoints were getting queried from GraphQL. So it did sort of work as sort of a gateway for us that would limit access to only the API endpoints that we built into the graph, if that makes sense.
Yeah, no, that's really impressive.
Well, I think that's time. Thank you, everybody.